Hello, and welcome to the last lesson of Unit 3. We're in Unit 3, Lesson 5, which is talking about writing function rules. A function rule is pretty much just an equation, but we're going to write them in function notation, so the f of x. We're going to be working with that. So we're going to do it from a table and then also a situation. A situation just means it's going to be a word problem, which we've actually done a lot of them. It's just writing it as a function instead of just a y equals. So in the following tables, we're going to identify the pattern that gets us from the domain, that's a D, not a D, the domain, which is our x value, to the range, which we have known as our y value, but I want to put this here because this also means y. F of x and y can be used interchangeably, okay? So we're looking for patterns today, from x over to the y's, and see how we get there, okay? Here's a really helpful hint. Try adding and subtracting first, and if it doesn't work, then go back to the first one and then try multiplication and division, because addition and subtraction is usually easier to spot. So I tell kids, start there, and if it doesn't work, back up. So what that means here is we're looking from x to f of x each time, okay? Like, how do I get from x to f of x to f of x? You're going to do that and see, you're going to kind of notice a pattern, and you're just going to check to see if it works, okay? So how do I get from 0 to 3? Well, from 0 to 3, I would probably start at 0 and add 3, okay? So I would plus 3. Just check to see if it works. 2 to 5, is that pattern still adding 3? It is, because 2 plus 3 is 5, okay? Check it again. Is 4 plus 3 7? Yes. So adding 3 to this column gets you the y column, or the f of x column, okay? And it works here as well. So you're looking for that pattern. How do I get from x to f of x? I added 3 every time. I started at 2, I added 3. Started at 4, I added 3. Okay, so the pattern is we add 3 to x. Because I start here, and I do 0 plus 3 equals f of x. Okay, that's how you have to think about it. What am I doing to x to get here to the right side? So my function rule is going to be, I'm adding 3 to x, so x plus 3, but then you have to say, what does that equal? Well, it equals this right side of the table, so f of x equals x plus 3. Okay, so I'll write that a little bit better here. F of x, the right side equals the left side plus 3. So f of x equals x plus 3. Okay, see how we get from the pattern to the actual function rule? So let's try it again. How am I getting from 0 to 0? 1 to negative 4. 2 to negative 8. Okay? Well, here's the thing. 0 to 0 is kind of hard to understand. So we're going to go from 1 to negative 4. How would I get from 1 to negative 4? Well, I subtracted 5. Okay? Because 1 minus 5 is negative 4. But let's just write this. If I subtract 5, does that work here? Is 0 minus 5 0? No, it's not. So this does not work. That's why I'm saying start at subtraction and addition. If it doesn't work, go back and try something else using multiplying and dividing. So how would I get from x to y, 1 to negative 4, using multiplication or division? Well, since it got bigger, probably multiplying by negative 4, okay? That means multiply, not an x. Let's just check it. 2 times negative 4, does that get negative 8? Yes. Negative 3 to 12. Negative 3 times negative 4 does get me a positive 12, okay? So the pattern here is multiply negative 4 by x. That was the pattern. And 0 times negative 4 is 0, okay? So then write it as a function rule. Well, it equals this y side, so y equals negative 4x, because I multiplied x by negative 4, okay? So that's how I'm getting that. You can always check by plugging in these values into x and see if the y works, just like what we've been doing, okay? So we're going to keep moving. Number 3, how do I get from x to f of x? Well, let's start in the positives, because positives are easier. How do I get from 9 to 4? It looks like I subtracted 5. but let's just check. 6 minus 5, yep, that equals 1. 4 minus 5 does equal negative 1. So all of these I subtracted. Now be careful here. I subtracted 5 from x. So you have to be careful about that order. Since I subtracted 5 from x, f of x, or the right side, equals x minus 5. If you do 5 minus x, it won't work, okay? Remember, test it. Plug in one of your x's. So I'm going to plug in 9 minus 5. Does it equal my f of x, which was 4? It does. So you can always plug in your x and y, or x and f of x, to see if they work, okay? And the last one, this one's kind of weird. So here is how it works. The pattern, 0 to 15, 5 to 10, there really is no rhyme or reason from 0 to 15. Is that 5 to 10? Like here I added 5, here I added 15, like nothing's kind of matching up. So what you kind of got to think is there a situation between the both of them? Look what, if you added each of these up, look what they all add to. They all add up to 15. X and f of x equals 15. So this one's kind of weird because it's actually x plus f of x. The two columns added together equals a number. Okay, so this one's kind of weird. You won't see this, but this stuff's important, so that's why we're doing it. But I do want it in function rules, so I'm going to subtract x over. So f of x, because this is how a function rule is written, is actually 15 minus x. Okay, so that is my function rule. All right, that's a weird one. But what is important is how to do this. So that's why we went through it. So how to do this, super important. You will have to do it. What is f of 20? 20 is the x here. So we've done this before. This is saying plug 20 in for your function rule, in for x. So I would say f of 20 equals 15 minus 20. We've done this a ton. In your calculator, what's 15 minus 20? Negative 5. Okay, that's important, that you know how to just plug in a value into your new function rule. This one is also super important and new. What is the x value when f of x equals 3? So look at your function rule. Since f of x equals 3, 3 is being plugged in on that left side, equals 15 minus x. And I'm solving for x here because it's asking what is the x value. So I'm going to subtract 15, that equals negative 12, equals negative x. Well, I want to get rid of that negative. So x equals positive 12. You have to know how to do that as well. When it's asking, when it says f of x equals 3, that goes in for the left side. It does not go in for x, okay, because I'm solving for x. See the difference between those two, hopefully? If you didn't, stop, rewind, and rewatch again, okay? All right, so now that we just did tables, we're going to go into like a situation or an application. So we've done this before, okay? But we have to get in the habit of writing it as a function rule instead of just an equation. So write a function rule to determine the final cost. So final cost is this, of buying n ounces of frozen yogurt. So a cup of frozen yogurt at Yo-Yo costs 0.49 per ounce. So already you should be picking out what this will look like. So my cost, my final cost, we're going to see what this equals. C of n is my cost, equals 0.49. We've done things like this, just worded a little bit different. And then what's my variable? They give it to you. 0.49 times n, because n has to go with per ounce, okay? Now it's the important part of how to use it. How much would a cup cost that weighs 8 ounces? So 8 ounces has to go in for n because n is talking about ounces. So this situation is I'm plugging in 8 for n. And I'm just plugging this part into my calculator, just like what we've been doing. It went in for my variable. So I would put that in my calculator and get 392. That is my cost. This is saying this is my cost when I have 8 ounces. That's what that is saying right there, okay? Now this one, how many ounces could you buy with $6? $6 is the money I have. So that's technically my final cost because I can't go over $6. So this has to go in for C of n. So I'm going to write the basic one again, 0.49 n. 6 has to go in for C of n, okay, not n. So you have to know when to plug in where. If it's so you have to look at what it's talking about. Here I was talking about ounces, so it went in for n. Here I'm talking about cost, so it is being set equal to the type of equation, okay? And then divide. So this is more algebra based, and I got that it equals 12 ounces. Okay? So we're going to try it again, writing an equation and then using the equation. To rent a hot air balloon, it costs $200 plus 21 per hour. A lot of you are probably already getting going on this, but you got to put it in function notation. Write a function rule to determine the final cost, C of H. So C of H equals, because final cost equals, of renting a hot air balloon for H hours. So it would be the cost equals, now go to here, 200 plus 21H. A lot of you will get this and then forget to set it equal to, you got to make it look like a function rule. It tells you what to set it equal to. Set it equal to your final cost. Okay? So now we're going to use this. How much would it cost, so I'm solving for C of H, to rent a hot air balloon for 6 hours? This is H, it's hours. So I'm going to plug in 6 for H and just do calculator work. And really no algebra here. Oop, I need to make that a 6. Okay? So I'm just plugging this in my calculator, see how many hours, what it would cost for that many hours. And I got 326. So what this is saying is for 6 hours, it costs $326. Okay? How many hours would you rent a hot air balloon if you had $400? You cannot plug 400 in for H because this is not talking about hours. Instead, it's going in for C of H because it's the cost. So I'm going to have 400 equals 200 plus 21H and solve for hours because I need how many hours? So I better solve for H. Subtract 200, subtract 200, 21H equals 200, and divide by 21. So I get about 9 hours. For 9 hours, I could get 9 hours worth for $400. Okay, don't round up because then you'd go over. Cool? So that is how you do your generic ones. The last one. Write a function rule to determine the change you would get from a $20 bill when purchasing items that cost $1.25 each. So this is kind of weird. So I'm going to call items, just write this down, items will be X. Okay, number of items. Okay. I'm going to call C of X my change. So I'm going to set C of X, my change equals, now think about how you get change. You get change by spending money. So you start with $20 bills, a $20, and then you have to subtract every item that you purchase. Okay, so write this down because that's important on how to do change. You start with your amount and you're taking off, okay? So you're subtracting 125. So how much change would you receive if you purchased 5 items? Items is X, so C of 5 equals 20 minus 125 times 5, and you should get $13.75 in return. Okay? Now here, can you purchase 17 items with a $20 bill? Okay? So what I'm going to do is plug in 17 into my function. So C of 17 equals 20 minus 125 times 17. What I get is negative 125. So no, you would have spent over. You'd be in the negatives, okay? So that's what we're talking about there. So your homework is on Go Formative. Please show your work, especially for the word problems, and I will see you tomorrow.